All right. Hi, everyone. Welcome to Hashi Talks. And I'm glad to be here presenting this. And I would like to thank HashiCorp for giving this opportunity. So today I'll be presenting on the boundary and its integration with the vault. Um, so started working on a POC for a customer who wants to take advantage of the boundary with one of the use case. And let me go and kind of make sure that we all understand the use case here and then the problems with the current solution and how the boundary fix those problems, right? So the use case is pretty straightforward, where they want to have a group of users. The users are members of support engineers or auditors to perform the routine task on getting onto target systems within a private network, right? Pretty straightforward use case. We have seen this a lot, and basically, they can use their existing VPN solution to address this use case where the end users get access to the private systems within their private network. So some of the challenges with using a VPN solution is, first, they had to provide end users a separate set of credentials to authenticate to the VPN system. And there are multiple VPN profiles exist today for the customer, which end user has to know which system to use, and then maintain the different VPN credentials, which is obviously makes onboarding the users very difficult, right? So once they authenticate to the VPN system, now the challenge is they are on the network and they could access other sensitive systems on the network, which they're not supposed to. And the next challenge here is the authorization of these target systems within a private network, right? So today, the authorization happens with the network firewall using firewall policies, and it works very well with the static environment. But as the target systems are within a AWS auto scaling group, has uh, IP address changing as the systems scale up, scale down, right? It's very challenging to keep those firewall policies up to date in a dynamic environment. And the last challenge with having the users connecting to the target systems is maintaining the SSH private keys, providing that to the end users. And that's a big security risk, where if those credentials get exposed or compromised, then, and on top of that, had to rotate those credentials. So that's a huge security risk there itself. So having all those challenges, we were doing a POC, see how the boundary and integrating the boundary with the vault would fix some of these issues, so their end users can perform their routine tasks connecting to these systems within the private network, right? So my name is Kalam Abdul. I'm a cloud architect. In my role, I help solve some of these problems that we discussed just now, right? And I help customers in the platform engineering and designing and implementing Hashi suite of products across multi-cloud, right? So how do we solve this problem with the boundary, right? So let me kind of understand you what is the boundary. So boundary is a software solution that provides a secure remote access to the infrastructure services, and it is based on identity aware proxy that sits between users and the infrastructure they wish to connect, right? And what is identity aware proxy? It basically provides secure access to the targets based on user authentication and authorization, instead of relying on network level firewalls, right? So how do we address those issues with the boundary in here, right? So some of the challenges I brought up before, and how do we address those challenges using boundary and the vault within this dynamic workflow, right? So in here, the users, they can authenticate by using their existing identity provider. So they don't have to maintain a separate VPN credentials, like to connect to the VPN system. They can connect to the boundary by just integrating with the existing identity provider. So that makes onboarding the users a easy process. And once they are authenticated, the authorization happens based on the policies that are assigned to the users, right? So, and these policies are based on the logical service level, not at the IP level, which works very well in the dynamic environment. So, if the IPs, the changes for the backend systems, that policy still is good for the users to connect. And the third challenge that we discussed before was having the user on the network gives access to other systems as well. But in here, using the boundary, it allows the customer or the end user to only connect to the host or services that user has access to or permissions applied using the policies, right? So with this, we can control what users can connect and what not, right? And the last challenge with providing those SSH credentials to the target systems, where in here we can connect the boundary, integrate the boundary with the um, HashiCorp vault, where it can retrieve or gets the credentials and inject into the session without even having to expose those credentials to the end user, right? So that makes a workflow a lot secure, and users only get to see what they have access to, right? So Boundary is a open source, and Hashi also provides a fully managed version of the boundary. It's called HCP Boundary. It enables zero trust networking without needing to manage underlying infrastructure. And the boundary, HCP Boundary, has two main components in here, right? The control plane and the worker nodes. So the role for the control plane is manage the state for users, host, and all the policies you create within the HCP boundaries, all managed by the control plane. And the worker nodes are assigned by the control plane when the user initiates a session with the target system. And these are serverless proxies that are basically a way to connect the end users to the target systems, right? And the way you can deploy these managed worker nodes are the Hashi provides you a self-managed worker node as well, right? Why would we need self-managed worker nodes is in a case where you have the target systems running within a private network, right? Then you could use the self-managed worker nodes so that you don't have to expose the worker nodes or the target systems to the internet. And the second use case is where you have a private vault cluster that runs within a private VPC network. And for the control plane to connect to this private cluster, you could deploy a self-managed worker node within a VPC without having to expose the vault cluster to the internet, right? So what are the network requirements for this to work, right? So when you have the self-managed worker node within the VPC, all it needs is a outbound traffic on port 9201 to the control plane, and the outbound traffic to the target systems, right? So in the only inbound traffic the self-managed worker node require is for the end users to connect to the who once they open up the session to connect to target system, they need to see the worker node on port 9202. That's all inbound traffic it needs. So taking one step back, now that we understand the architecture here with the HCP boundary, it needs a control plane and it needs a self-managed worker nodes and the connectivity to the external or to the vault within a private VPC, right? So to register to set up the infrastructure, so after we create the HCP boundary cluster, the next step is registering the worker nodes, right? So with the config file you see is a sample config file that you create for worker node so that it can run that config file and register with the control plane, right? So a couple of things here is you had to provide a HCP boundary cluster ID in the config file, and also it's private IP address. Even though it says public address, it still works with the private IP address of that EC2 instance where the boundary worker binary runs, right? And then you can provide the tags to this worker node, so they could be used for when you create a target inside the boundary. You can specify which worker nodes to be utilized for that target, right? And also you could use these tags so the control plane can choose which self-managed worker node to connect to get to the vault, right? So providing this config file to the binary, and it gives back a worker auth registration token, and this will be provided to the control plane to register this worker node, right? So now that we have control plane, and we also have the self-managed worker node running within a VPC network, and now it's registered with the control plane. So we have the whole infrastructure now. So the next steps we need to enable or apply is a domain model or the boundary resources within the HCP boundary, so we can create those sessions for the end users, right? So when you have created the boundary HCP cluster, by default, it gets a global scope, which is basically a root namespace in the wall, right? And within this global scope, you could create auth method, roles, groups, and also a organization scope. It basically namespaces in the vault domain model, right? So you can create this organization scope, and in our use case, we map this organization scope to the customer's business units. So since the support team falls within a operations business unit, the scope we have created is at the operations level, right? So we have a scope called operations, and within the scope, as you see here, we have a OIDC auth method, which is basically Azure. We took the Azure identity provider here, so that users can authenticate to the Azure OIDC, and based on the JOT claims attached to the token, right, they will be assigned to a OIDC dynamic groups. And the claim we're looking for is a department. And once the department the claim has value operations, they get assigned to that dynamic groups and their roles. And within the organization scope, the project we created is called support. So you can create multiple projects within an organization scope. As you see here, we have a project support. And within the project support, there is a role that has proper permissions to the group. So the group that's at the operation scope level has a role assigned at the project level that gives the permissions to the support team to connect to their target systems, right? So now that we have infrastructure and we have authentication set up with the OIDC auth method, with the dynamic groups, users can authenticate to the organization scope, and now they had to be set up a target systems, the host catalog, and the credentials to connect to the vault, right? So let me go into the next slide in here and kind of talk about what is a dynamic host catalog. So this is a very important feature within the boundary that allows you to create a dynamic host catalog plugin. And today it's supported for AWS and Azure. So how it works is once you register the plugin within the boundary, it helps you to add the backend systems dynamically to the host catalog, right? So in a scenario where you have a auto scaling group or adding new instances to your in your AWS region based on the plugin you enable in that region, you don't need to manually add those targets, the backend instances to the boundary target or to the catalog. So they will get added automatically. And once you have the plugin enabled, you can create a host set. So what is the host set is here. You can use the tags filter. When you create EC2 instances, you can provide the tags. You could use those tags to group a set of machines into a host set. So since the support team may need to get to the app tier 1, app tier 2, now you can create the host sets based on the tags called app tier 1 and app tier 2, right? And to create this dynamic host catalog, you need IAM keys in the AWS and the right permissions to read the EC2 instance and the tags. And once you have those role created on the AWS side, you can use that to and create the host catalog and create the host sets using the filters, right? So that will get you the host catalog and the host sets, right? So once you have all of that, the next step is creating the credentials library. Basically now you need to tell the boundary how it will connect to the vault and where to read those secrets, right? That's where comes the credentials library in here. So today the boundary supports external vault, and it also has a built-in credential store in the boundary. And to configure this credential store, you need to have a token that can authorize to the vault, and one and it needs a specific policy that will be created on the vault side. And having the right permissions in that policy, you could create a periodic token using that policy. And to create a credential store, you basically provide the vault address and provide the token that will get you the credential store. And once you have that, you need to create a credentials library, which basically tells where is that secret located within the path to the secret in the vault, right? So once you have all of that created in here, now is the end users, once they authenticate to the boundary, they will be able to see the targets. And once they connect to the targets, there will be a session established where the control plane will talk to the vault cluster, retrieve the credentials, and inject into the worker node. So, and they can get connect to the target system without even seeing those credentials, right? So with that, some of the important thing, audits, right? So we need to make sure the audits are enabled so we can go back and see who access what, right? So today Boundary supports customer managed Datadog and also AWS CloudWatch. To enable the audit logs, you need to have proper ARM role set up on the AWS and with the proper permissions. And you can use that role in HCP UI to enable the log streaming, right? So you need to have proper role with the permissions. So all the inbound or all the response and request to the boundary will be logged, and you don't need to set up a separate logging for self-managed worker nodes if you're running those in your environment, since everything is get logged on the control plane. uh, but the same thing is not for metrics, right? If you want to have a metrics monitor, then that needs to be collected from self-managed worker nodes. So with the boundary involved, we're able to achieve some of the zero trust principles, which is verifying explicitly the credentials, and also we just providing a least privilege access. So the end users only see the systems they have access to, and we have now proper audit to see all the requests and responses happening, or the sessions happening within the control plane, right? So I got a quick demo in here to show the with the boundary CLI. I'm sorry, I think I did not probably make this large enough in here, but so this is a demo that is using a boundary CLI in here, right? Before the end user, this is the system where end user is where it's trying to connect to the boundary, right? On this system, end users had to export some of the environmental variables like cluster ID and auth method ID, and they can use that to authenticate to the boundary with the boundary authenticate OIDC command, and they get the token from the control plane. And once you got the token, you can export into an environmental variable. Since I'm using a OIDC identity provider here in Azure, is making that call to Azure and verifying your credentials. And now you get the token back, and you can use that token to connect to the boundary and list the targets. You can probably you can see now I'm running a command now here to list the targets within that scope, and the target you see is a dynamic host set. And now you can use boundary connect target with that target name that will allow you to connect to the backend instance and without providing any credentials in here. So boundary connect and then type SSH and the target ID, and then you should be able to connect to the target instance. That's the target instance that end user is connected to now without even providing any sort of credentials. And also the boundary has a desktop application. If somebody has to not very familiar CLI, they could use the desktop application in here, and pretty much the same process in here. They launched the desktop application, and they could use the Azure OIDC at the operation scope to sign in, and they get the token back from the control plane, and they should be able to see the targets within the boundary desktop application. Once they authenticate the OIDC, now they should be able to see the targets in here. So the very top, the below one is the one with the dynamic host set, and once you hit on connect, it will provide a proxy IP address and the port number that you can use on your system to SSH to the target instance by providing the proxy URL and the port address, port number. You should be able to connect to the end instance. Now we got into the EC2 instance. So it's pretty straightforward. So this kind of helps some of the challenges with the VPN, and we were able to successfully demo this with the POC for the customer, and they're very close now to getting the production. And thanks for taking the time to join the Hashi Talks. I'll be here for any questions if you may have.